Welcome back to AI Breakdown, where we sift through the latest research papers in the world of artificial intelligence. This is Megan, and with, as always, is my co-host, Ray. Ready for today's deep dive, Ray?
Always ready, Megan. What have we got lined up?
Today, we're reviewing a paper titled Self-Taught Optimizer, STOP, Recursively Self-Improving Code Generation. It introduces an intriguing method using a language model to enhance a program written in a language like Python, aiming to optimize solutions to various tasks. The method is called the Self-Taught Optimizer, or STOP.
That's a pretty interesting approach, Megan. So if I get this right, the authors use an initial improver program that uses a language model to optimize a solution. They then have this improver program refine and optimize itself. The end goal is a highly versatile improver program. Cool, isn't it?
It is, Ray. They back their theory up with experiments using the GPT-4 language model. The results show that the self-improved improver program can perform noticeably better than the original seed improver program on a whole host of tasks. It's almost hard to believe that a language model like GPT-4 can actually generate code that improves itself.
So essentially, they explored a few self-improvement strategies for the language model.
You've got it. They tested strategies like beam search, genetic algorithms, and simulated annealing. These are meta-heuristic methods combined with other fresh approaches like decomposing and improving parts of the solution, which served as scaffolding to guide the self-improvement process. As a bonus, they provide enough details and code examples for reproducibility.
That's precious, especially for the research community looking for reproducible experiments. Did the authors shed light on any potential concerns tied to the development of self-improving technologies?
They sure did, Ray. They take a deep dive into the ethical considerations and raise questions about the fast pace of evolution in self-improving technologies. They even calculate how frequently the generated code was able to bypass a sandbox, something that gives us an idea of potential unintended consequences. The transparency provided by the interpretable code produced by STOP enriches our understanding of any unintended behaviors.
Yes, being able to interpret code is absolutely necessary when building any AI system. Were there any caveats to their research?
There were a few, Ray. One of them is that the language model itself doesn't get any upgrades during the self-improvement process. Another is the roundabout way of assessing improver quality, which is largely dependent on the performance of downstream tasks. They also muse about the possibility of reward hacking in the downstream utility function and suggest some techniques to ward off such scenarios.
I noticed some interesting figures and graphics in the paper too.
Good observation, Ray. For instance, Figure 1 provides a clear overview of the self-improvement strategies used in the process, and it's very insightful in general. Figures 2 and 3 give a detailed explanation of the seed improver and self-improvement pipeline, respectively. Figure 4 charts the meta-utility of STOP over different iterations for varied tasks, and Tables 1 and 2 provide valuable stats on the transferability and potential security issues. A thorough read of these is highly recommended.
Thanks, Megan. This paper holds quite some promise for self-improvement in code generation via language models. It's fascinating how the self-improved program outperforms the base one.
It does open some exciting doors, Ray. But it's equally critical to remember the potential risks and ethical considerations that might pop up with the rapid development of self-improving technologies.
Agreed, Megan. And with that, dear listeners, if you enjoy delving into the world of AI research with us on AI Breakdown, please consider leaving us a review on your favorite podcast platform. It really helps us bring these discussions to more people.
We truly appreciate it, folks. Join us for our next episode, and until then, stay curious.
Curiosity is the way to go. Bye.